All right, we're going to go ahead and do the 4.2.3 quiz for Algebra 1, a slope-intercept equation of a line. The slope-intercept equation is y equals mx plus b. So what's in blue is just like the generic pieces of the equation that we're really not going to do a lot with. The y and the x just represents the ordered pairs of all the points on the line. So it represents every single solution to the equation and every single point on the line. So that's all the y and the x is, just that ordered pair. Now the pieces that we're going to use in this equation is the m, and the m is the slope. And we just had the last section that covered all the slope stuff. So we know how to calculate the slope using our rise over run formula, y2 minus y1 divided by x2 minus x1. Right, that's all the last section stuff. The new piece for this section and for this equation is going to be in the green, the y-intercept. So the b term in the equation, all right, so the b term in the equation is the y-coordinate of the y-intercept. And just to explain that real quick is we have x and y as just an ordered pair. This y would be the y-coordinate, all right, the y piece of it. Okay, so what we're saying by the b being the y-coordinate of the y-intercept, it is just simply an order. A y-intercept is an ordered pair, and the b just goes into the y section. All right, now what is the y-intercept? Well, what does intercept mean? Intercept's like intersection. It's where you cross paths. So the y-intercept is where the graph of the line, in my example down the bottom in gold, that's the line, is where that line crosses the y-axis. So it crosses the y-axis right here, in, and I marked it with green, and then the ordered pair for this would be 0b, where b is however high up on this line it is. All right, so that is that y-coordinate piece. All right, so 0b, and the y-intercept will always, always, always have an x value of 0 because the y-intercept has to be on the y-axis, and the y-axis, x is always equal to 0. So the y-intercept will always have an x value of 0. Repeat, the y-intercept will always have an x value of 0. All right, let's go into this checkup. Now, so the graph of, so we're doing the graph of y equals negative 7x minus 10. All right, so if I'm just going to kind of break this down. It shows, okay, well, I guess we'll answer it first. It's a line. All right, and that shows all the answers. Shows I guess the technical, they want like the set of all solutions. So basically whenever you graph, and I'll go down to this example below, is like you graph a line, you get this line. This red line represents every single solution to that equation. Every single point going down to however many decimals you can find, every single one of these points represents an answer to the equation. All right, so that's what it's saying, is that this graph is a line that shows all of the solutions. Now, what is each piece? Well, the number, if we go back, the slope was the coefficient of the x, right? It's m times x. Whatever number is in front of the x is your slope. So this 7 is right there in front of the x. Well, that's my slope. And then the b, the y-intercept, was kind of by itself, right? So it's a plus b. So if this was negative, we would have to take the negative with it. And now the y-intercept, everybody's going to be like, well, y-intercept's negative 10. And I'm going to tell you wrong. Now, in a lot of our practical use, we just say the y-intercept's negative 10. Everybody kind of accepts it, and we all know what we're talking about. But we should be proper, and I think Apex is going to want us to label it properly, is technically the y-intercept is, because the x value is always 0, is going to be 0, negative 10. All right, so that's the y-intercept right there. That's your b. That's your m. All right. So 3, they want us to graph. So, and we can always, just so we know, we're always able to use Desmos.com. It's a graphing calculator, and we'd be able to type this in. It will show us the graph. So just remember that. Now, for this equation, what I'm going to do is I'm going to go ahead and label my slope is negative 2. All right, and then my y-intercept, well, my b is negative 1, so that means my y-intercept is 0, negative 1. So they're telling me to plot the y-intercept. I'm going to do a little bit more. So I'm going to plot the y-intercept. So it's 0, negative 1. So my y-intercept is going to be right there. And in case you can't hear, there's the noon Wednesday siren going. All right, so there's my y-intercept. Now I'm going to go ahead and I'm going to use my slope to kind of get some different points. Now I have a slope of -2, and I can just say this is -2 over 1. And what I'm going to say, this is a -2, so this is down 2 over to the right 1. So I go down 2 over to the right 1. Down 2 over to the right 1. All right, so I got those points there. Another way is I can reverse this. I can go, or I can go up 2 to the left 1. 1, 2. So I can go backwards as well. And then I can just connect. And there is the graph of that equation, which again, we can use Desmos, make our life a little bit easier on us. Ooh, so now they want us to write the slope-intercept equation. The first thing I'm going to do is I'm going to write my slope-intercept equation, which is y equals mx plus b. All right, and then I know if I go back to my example over here that the only pieces that I'm changing are the m and the b. That's it. So if I go back and rewrite this, I know I'm going to have a y equals, well, a blank x plus blank. That's where my m goes, and that's where my b goes. All right, so that's what I'm going to solve. Well, I'm going to start with the y-intercept because it's usually the easiest. I need to find out where this graph crosses the y-axis. Right there. That's where the graph crosses the y-axis. And that is 0, 4. They actually already gave me the ordered pair there. But if I didn't, all right, I'm on the y-axis. 1, 2, 3, 4. So it's 0, 4. So my b is that 4. Put that right there. Now, I'm given one ordered pair, 0, 4. And for me to calculate a slope, if we recall, right, just from last section, that our slope formula is y2 minus y1 divided by x2 minus x1. So we actually need two ordered pairs. Now we're given another ordered pair, but we aren't told what the coordinates are. Like we're given the point, but we're not actually given the ordered pair, I should say. Well, I'm going to count it out. I'm going to start at the origin. I'm going to go 1, 2. All right, so my x value is 2. And then 1, 2, 3 up. So 2, 3 is the other point they give me. I'm going to go ahead and I'm going to label this. This is x1, y1, x2, y2, and then I'm going to plug this in. It's going to be -1/2. It's kind of sloppy. So you get -1/2. And then I'm going to clean this up and say y equals -1/2 x plus 4 is my equation. All right, so the function f of x is shown in this graph. All right. Sorry, okay, so f of x is shown in this graph. The function g of x is equal to -3x minus 1. We want to compare the slopes by writing less than, greater than, or equal to. Well, the only way we're going to be able to do this is we're going to have to actually calculate our slopes. So we have 1, 2, and then 1, 2. So this is going to be an ordered pair 2, 2. And then I need to go ahead, I need to label these, right? Because I got to calculate a slope. So I got x1, y1, x2, y2. I need to compare slopes, so the only way for me to do that is to actually calculate the slope. Move this over so I get more space on my tablet here. All right, so y2 is 2, y1 is 3, x2 is 2, x1 is 0. So this is going to be a negative 1/2. All right, so that's my slope. So my slope of the f function is negative 1/2. Now, I didn't mean to do that. What is the slope of the g function? Well, just a reminder over here that the slope is always that number in front of the x. It's always the number multiplying the x. So in this scenario, my slope is this negative 3. So the slope of f of x, so negative 1/2. So I'm just going to go ahead and write that. So negative 1/2, negative 3. Is negative 1/2 less than, greater than, or equal to? It's definitely not equal to, right? Negative 1/2 is less than? No, it's greater than. Right? Because the negative 1/2 is bigger than the negative 3. Right? It's a little bit different, right? Don't be worried about the numbers, right? The negative number. So negative 1/2 is greater than negative 3. All right. Now this next one, right? Now we're given a word problem. Now we have to create our own equation. How do we do this? All right. So they tell us that the temperature T in Fish Haven, Idaho starts at 20 degrees Fahrenheit at midnight when H equals 0. The temperature drops 2 degrees every hour, so we know that this hour, this H means hour. What equation represents the temperature T at hour H? So how I'm reading this is that the T is going to be my Y value and the H is going to be my X value, right? So in terms of all my thinking, T would be my dependent variable and H is my dependent variable. All right, so I'm going to go ahead and say it's T equals, just like I would normally, again, if I go back to my equation, have Y equals, all right? So what we're going to have is instead of writing Y, we're going to write T. We're still going to have an M, and instead of writing X, I'm going to write H. And I'm still going to have a Y-intercept. All right, so I'm just changing my X and my Y to be different variables to represent a real situation. So instead of being Y, which would be meaningless in this scenario, we're going to use T for temperature because that's what we're tracking. And instead of having X to represent my independent variable, just randomly, I'm going to use H because we're specifically talking about hours. So don't let the change in variables change what we're doing. It's all the same stuff. All right, and they give us a tip, the rate of change or slope, right? So they tell us right away that the slope is -2. Well, where does that slope go? I know we were just there, but where's the slope go? The slope always goes in front of the independent variable, usually the x, but in this case, the h. So if they're telling me that the slope is -2, the slope is -2, it goes first, and then h is my x. So h is the one thing that's going to be multiplied by the slope. All right, and now, what is the y-intercept? Now, what I haven't talked about yet is the idea that a y-intercept is a starting point. All right, it's wherever you start. All right, it's always that point on the y-axis, but a lot of times in real life situations, we don't really have a lot of negative, so like for this scenario, we can't have negative hours. All right, so we can't really go left into the negative. So whatever starts on that y-axis where x is 0, where the hours is 0, that's where we start. Well, where did we start? We started at 20 degrees. So we just add 20 at the end. And I'm sure a lot of you guys probably got this done 2 minutes before, and I just kind of wasted some words here, but I wanted to try to cover all the details just in case. All right, now, the cost C of x. All right, this is that function notation we've talked about and seen a few times. So C of x, I'm saying is my y, right? So that's my y value. All right, so C of x is equal to 2x plus 4, where x is the number of minutes. All right, so graph C of x, including the correct axis labels. Well, they told me that x is the number of minutes, so right here, I'm going to put minutes in that blank. So this is going to be minutes, right? Because that's my x-axis label, which means my cost has to be my y, which I already kind of labeled that. All right, and now they want us to graph this. Well, again, we can always use Desmos. Well, I guess it's over here. You can always use Desmos.com. I'm cool with that. But if we don't want to do that, I can take this 4, that's my y-intercept, right? So this is a 0, 4. Well, 1, 2, 3, 4. There I am. Now they're telling me my slope is 2, right? So it's a positive 2 over 1, so that means I'm going to go up 2 to the right 1. 1, 2, 1. Or, right, I can reverse it. I can go down 2 and to the left 1. If I reverse both of them, I'm good. Down 2 to the left 1. Down 2 to the left 1. And that'll be good enough for now. And I just connect them. And obviously that's a bad line, but that's okay. I'm just kind of sketching here. And then there's our graph. But as I just did this, looking, what did I make a mistake of? Actually, I had just talked about it. Remember when I talked about how the y-intercept was a starting point, and especially in like real life situations, it's more accurate being a starting point because with our Idaho example, like we can't have negative hours. So there's no situation we were going to the negatives. For this graph, right? For this graph, we're talking about cost in minutes. And over on this left side of the graph, where the left side where almost all the blue is, that would mean we would have negative minutes. We'd have negative time. Is that even possible? Absolutely not. So my graph really should just be that. That's all it is because it doesn't exist to the left. That domain doesn't exist. If you remember talking about domains, all the possible x values. Well, if our x value is minutes, we know we can't have negative time. So we would just have this short small graph and we wouldn't include the left of it. All right, so in Moose, Wyoming, so Wyoming, Idaho, we're kind of hanging out there. The snow level is modeled by the function y equals 2x plus 14, right? So if I'm not reading the rest of the problem, I'm looking at this. I know that this 2 is my slope, and I know this 14 is my b. So I have a y-intercept of 0, 14. I have a starting point of 14, and I have a slope of 2. Now I don't know what those represent yet, but I know exactly from the equation, from that slope-intercept equation, what those two things are. All right, so y is the amount of snow in inches, and x is the number of hours after midnight. So what is the meaning of the y-intercept in terms of the problem? All right, so what I would do for this is, what is the y-intercept? What is the meaning of the y-intercept in terms of the problem? Is basically, I'm just going to plug 0 in for x, right? Because that's what the y-intercept is. It has an x value of 0. So I have this equation, y equals 2x plus 14. I want to kind of think about what this is. So if I plug a 0 in for x, I really just have y equals 14, right? Because 2 times 0 is just going to cancel out. So what does y equal 14 mean? Well, y was the amount of snow in inches. So what this is saying is that there are 14 inches of snow at midnight. So before we even started counting after midnight, there are already 14 inches of snow on the ground. All right, again, it's our starting point. We started with 14 inches of snow. Now, let's see if I can move this. There we go. All right, what is the meaning of the slope in terms of the problem, right? So if we know that x is the number of hours after midnight, so x is the hours, the slope, that 2 is multiplying the hours. So for every hour, it's going up by 2. So what the slope means, what our rate of change means in this problem is that it is snowing about 2 inches per hour. All right, so it's changing 2 inches per hour. Since we're talking about snow, it means we're adding 2 inches of snow. All right. And now, what was the snow level at 8 a.m. when x equals 8? So 8 a.m. is 8 hours after midnight. So if we know that midnight was 0, we'll know that 8 a.m. is 8. And I am just going to take my equation, y equals 2x plus 14. I'm going to plug 8 in for x. And it's going to be 30, and I should add my unit because we're specifically talking about inches of snow. So I have 30 inches.